Welcome to the Mr. Beacon podcast. Range anxiety is a major factor in purchasing decisions, not just for EVs, but IoT as well. The amount of time I've spent talking to potential customers, clients about the range of different tags and beacons, you can't get that time back. And there are good reasons for it. Sometimes there are not good reasons for it as well. But this is something that is progressing as the technology's progressed from Bluetooth going from tens of meters to up to a couple of hundred meters. But what about 600 kilometers? That is the altitude of the Hubble satellites that are connecting with tags and trackers that are moving around the United States using the same hardware that is used for Bluetooth beacons. I have been fascinated by this convergence of IoT and space travel, and I've been wanting to speak to the folks at Hubble for a very long time, and I am really delighted that this week's episode, I get to do that with Art Tkachenko, who is head of software for Hubble. And his domain is really broad, from the firmware that goes on all the different chips that can beacons and tags, to the orchestration of the satellite or satellites that are traveling around the Earth in orbit. And it's really fascinating. So check out this conversation that's coming. We go deep and really broad. We cover what Art thinks about AI development and how they're using it, as well as the use cases that they cover with this amazing technology. I think you'll find it very interesting. So Art, welcome to the podcast.
Thank you. Happy to be here.
I've wanted to get Hubble on the show for years, I think, since you first announced. And, what you're doing is super hard and it's big. Oh my goodness, the scope is massive. So, and you lead software development. How do you describe what Hubble does to people when you meet them and for some reason they haven't heard of your company?
I mean, the one-liner is Bluetooth to space. Little more is we enable most prevalent chip in the world, Bluetooth, to talk to our constellation of satellites. We have launched 7 satellites, and we enable connectivity with the global coverage with the devices that cost less than $4 with whole BOM in, like just full-blown BOM, $4, talk to space everywhere in the world. I'm not in marketing. You can tell. I love what we do, but my summaries. And I do want to emphasize that we have 2 networks. So the goal is the satellite, of course, is the sexy part. It's awesome. It's hard. It's super hard. It's super, I have to say, creative solution to a big problem, connectivity. But the company's mission is IoT connectivity in general. And satellite is not always the right solution. So we have right now 2 networks. We have the terrestrial network, around 90 million terrestrial gateways. And in many cases, it is the right option. Energy efficiency is significantly better. But it's mostly in the urban, suburban areas. But everything else, satellite is the way to go. And as I said, we try to support every Bluetooth chip and let it talk directly to the satellite. So if you're tracking a container going from Bangalore to San Francisco, you will use one network. In the more dense environments on a transit, you will use the satellite, and then together it gives a sort of end-to-end visibility of your assets. No Spotify to the sky. We're definitely not doing high throughput connectivity.
Right. It's good for a few bytes, but
exactly.
Yeah.
It's really, let's say 50 bytes per day, split equally twice per day, giving the constellation size right now. But it is enough to know where things are, where your assets are, and then if you have some telemetry on each transmission, you add your custom payload where you can put like temperature values, or other critical information like gas meters, level sensing, etc., into that payload. Yeah, that's what we do.
Very good. And there's just so much to talk about from the use cases. And yeah, I think a lot of people who are in this business are sci-fi nuts. So the fact that you're combining space and satellites with
Mm.
auto ID, amazing. So I've got a ton of questions
Bring it on.
to kind of drill into, but I do want to make sure that people kind of get the basics clear in their head before we start drilling down. So the two networks is an important thing, and they're both very large, powerful networks and complementary, as you said. You know, there's the satellite one, you can be presumably in the Sahara Desert. I don't know what actually what did no. Okay. What is the coverage of the satellite network?
Officially, right now, so couple caveats. So one of the reasons I had to reschedule this twice, I apologize, is that we in the final push. So I get to play with this network for the last 2 years since we launched the first satellites, over 2 years. But we right now in the final push to GA release. So literally couple weeks. Our terrestrial network has been in GA for about 6 months now, general availability, and we now on the sort of final steps of bringing the satellite network by end of May to our customers. So not for me not to be so selfish and just being the one playing with all the devices and seeing how
Yeah.
awesome it is. For now, we're targeting US, but
Okay.
we do have interest across the globe, from Australia to South Africa to Europe, of course. Nuances and regulations. So for now, I would say US is our primary market, but we will, of course, expand. This is the global network. We can do everywhere in the Earth right now. Our satellites cover every part of the Earth twice per day. But commercial availability, we're starting with the US in the next couple of weeks.
Oh, so there's lots of reasons why, from a commercial perspective, I can see you would focus on the US. It's the biggest market, but you're using Bluetooth, right? So on the regulatory side, I mean, the great thing about Bluetooth, unlike RFID, is it uses the same frequency everywhere.
You're
So
correct.
do you have to, are there other regulatory issues because you're bouncing signals between space and the ground?
FCC definitely has a lot to say. We work very closely. FCC within US and then other government agency. I won't be the strongest person to talk about this, and especially the global part. We have amazing teammates, Al, on our team, who's just working through all of this. EU is a little more is nuanced. So, for
Mhm.
example, even you're right, this is not BLE, but the power limitations in Europe are different from US. So, for example, in US, BLE can go up to 20 dBm. In Europe, it cannot. But because we're not BLE, it's a different profile. We coexist for our satellite communication. We coexist with Bluetooth stack on the same chip. We shut down Bluetooth during our satellite transmission. We bring up our custom proprietary stack on the same chip. But again, nuances. Europe is a little different. So their levels are a little different. Their hopping requirements are a little different. We're designed to be global, but it is going to take some more work to actually be able to be approved across the globe. Something we're very actively working on right now.
Yeah, and I appreciate you're making that distinction. You're using these Bluetooth chips, but they're not actually using the Bluetooth protocol because obviously the range limitations are a little bit less than between a truck and a satellite. So, can you double click on that? And which Bluetooth chips does your solution work with? I've seen TI is probably the most recent announcement. Seemed like a really big one, but tell us a bit more.
Yeah, and I have to distinguish the terrestrial and satellite. Terrestrial, that the beauty here is that for terrestrial, pretty much any Bluetooth chip works, and that's we can do with the same single chip for the terrestrial, just utilizing existing Bluetooth capabilities, and then use our satellite stack when Bluetooth is not enough. So for terrestrial network, effectively all the chips, as low as in-play IN100, which is not even programmable but configurable chip, like the super cheap inexpensive chips that compete with RFID. We're talking about sub 20 cents BOM cost. So terrestrial across the board. For the satellite, we work closely with pretty much not all, but many chip vendors. We don't we took the direction where we don't have to work super closely, where they implement our stack at a very low level. They are radio controllers, which because we are relatively slow, our throughput is slow, we can effectively be at the application level, a higher level that's often exposed per chip. Different way chips expose the hooks differently, but we sit kind of at a higher level than the observed basic Bluetooth, let's say, physical level implementation. We work with TI, so for the GA, which will be within a couple of weeks, we support two targets from TI, 2340 and 2755. Distinction is that we do, for this version of our network, strongly recommend 20 dBm transmissions, so 100 milliwatt transmissions. Most chips don't have that level, so
Yeah.
you would have to have a FAM with front, like a ref amplification up in front of the chip. So when I
Yes.
say 2340 from TI, that assumes something in front of it to boost the signal. But we
Yes.
also support 2755, which is a 20 dBm option from TI. So those are
Oh,
two options
just
from
on
TI.
one chip?
It's one chip. 2755 is 20 dBm. Yeah, it's a
Oh,
single
nice.
chip solution. So same thing from Silicon Labs, which is now also TI. As of a couple months ago,
Yes.
the EFR32MG24 also does 20 dBm. And actually the board, if like once we really release this and people get to play, I'm just amazed that there's board from Seed. I don't know if you've heard of this brand. It's a popular hobbyist brand, and they have a line of products called Zio. So they have a Seed Zio MG24. It costs $7. It's like module that's probably a square inch less,
Mhm.
and that one talks to our satellites very well. Like I just love that board. It's just tiny, and it's super inexpensive, and it works. Along the same lines is Espressif, ESP32C6 support. It will be supported, and then there's a variety of Nordic devices. Nordic is very popular in IoT, so from 52, 53, and 54, 54L, all part of the GA release from Nordic. None of those are 20 dBm. They all require amplifications, but yeah, that's our initial set, and we'll continue growing as we work with other partners like Renesas and STM and NXP, and we'll just keep growing. Our goal is to support all.
Okay. And it sounds like it's not open heart surgery for to get those chipsets working. So that's augurs well, bodes well for your broadening the coverage. But how do I actually get a working device if I'm building my own applications or I'm a big end user? Where do I get beacons that can talk to a satellite in outer space?
Yeah, of course. A big part of our solution is make it very easy, developer friendly. We have this kind of whole work stream called developer first, and we take a lot of examples from companies like Stripe, and very comprehensive, well documented, easy to use SDK that you
Hmm.
bring into your development environment. And we target internally, we have a Zephyr user. Zephyr is our tool of choice. It's amazing because we do one implementation, we support lots of chips in one go. But the old SDK and reference examples designed for either bare metal, you can just take the C code, compile it in. We'll have reference example for FreeRTOS, which is still heavy for TI and Espressif environments. So we try to give examples as much as possible how to bring it into your design.
Hmm.
And then, of course, for enterprise users, we'll give you people, and we will work with you to integrate into your solution, really understand your requirements, your needs, and how to add our stack into your design. But the goal is really, in long term for my team, it is give enough tools to make it extremely easy to, self-serve, where we become we give all the best examples of all the right things to do when you develop an IoT device, from proper power management, OTA capabilities, protection, security, all those things. We have the experts in the house that we want to give you all the tools to just move really fast. Like, one of the internal gauges we have is how fast someone sign ups for us and gets the first device on the network. Like, this is one of the most critical metrics we track, is how easy it is to use our SDK and our documentation.
And how close are we to just being able to, because I'm writing apps with AI and that sort of thing, and I would just be interested in being able to buy tags that just work, no firmware development.
Oh, no work at all. I don't have the dates for that. We're working closely with all the listed vendors. Oh, no, vendors, silicon manufacturers.
Yeah.
With some, you will be able just to buy the part. With Hubble already being flashed,
Okay.
TI is definitely ahead, giving us strong relationship there. So the chips will come out well with the Hubble ready. For many others, we work close. We have a lot of work streams of integrating to the development tools. So like Nordic being part of their development tool, or Espressive being part of their development tools long term. So I don't have the timelines where you can just buy something that's ready to go. But even if that's not in place, we will give you instructions where you just buy a single board, you plug into your laptop, and we give you a single line you run. Just you open a terminal, run a single line, and that will take care of everything. It will provision the key, it will flash the key, it will configure the device, give it all the needed information for you to start using it right away, where you don't have to be embedded developer to try it out.
Okay.
We already have that. Like, for the terrestrial, we already have that. So if you go on our website, hubble.com, it will link you to our platform. We already have that for our terrestrial network. There's a single line, there's a list of supported boards. You copy that line in the terminal, and it just works.
Okay, but I can't go to like a Menu or one of those kind of off-the-shelf tag vendors and just say I want a tag that works with the Hubble network.
Not today, but you will, and including Minu as well. We are talking.
Yeah.
We're working with those companies like Minu as well.
Very good. Well, I can't wait, and presumably May is around. Is that when those devices are likely to be available, or is that really more a date for the production of the software that's running on the satellites and the developer platform that you have?
Don't quote me, but it's weird to say don't quote me on the podcast. The current goal, we'll see. I don't know when this is being released, but the goal is end of May, and I will probably bite my why did I say this? But end of May, everything is available, right? The SDK is released right now. It's behind the gates. You don't see the satellite part of our SDK. The terrestrial part is there, but end of May, satellite part is there. We'll list all the devices you can buy on SparkFun or Adafruit or Seed. DigiKey, the parts that will support, and with all documentations for you to get started.
Amazing.
I don't think we'll have devices pre-flashed in the market yet, so you'll have to do that single line kind of provisioning. But I expect that to come pretty soon after the GA, where you can just buy a ready device. But that's more of a marketing to people. I don't have much to say now.
And you're leading the software development, so I don't expect anything definitive, but you've given some hints in terms of price. So do you think we'll be able to get tags that will cost less than $10, or is that too optimistic?
I mean, the tag. So I can speak just what's right now on the market and what we're testing in our like real time with the satellite. This is one screen I'm talking to you, second screen right here, dashboard with all the performances of
Oh, I'd love to see that one. We'll do a screen share later.
and so the device I'm listing, like for example Zio, the Seed Zio, you can go on their website, and there's MG24 is, you can buy it today, and then once we go to GA, you'll be able to flash it. So the board's pretty much the day one. There will be options you can buy and easily program.
Yeah.
And some of those, I'll say, specific price points. It's a range. I'm talking, and often right now, a lot of those options will be just standard off-the-shelf dev kits.
Yeah.
So for example, TI's 2755, you just go on DigiKey, buy that dev kit, and it will be supported. But sort of a lower end, going back to the Seed, so the ESP 32C6 is one that's low volume, is $4 per board. Right now, you can just buy it.
Amazing.
And OMG 24, that's I think
Okay.
$7 in volume of 10. So we're talking about below $5 for a board that you can use right now.
So for a logistics use case where, I want to track this thing as it goes across the middle of America, across deserts and that sort of thing, then you can do that at a very low cost. That's pretty amazing. Well, there's more that I want to get into in terms of the use cases that you're focusing, because I see you are focusing on specific use cases. And I also just want to talk about what it was like to get this thing working in space and all that sort of stuff. But we should probably talk a bit about the terrestrial network, because we've kind of alluded to it a few times. I'm assuming that is using the Life 360 network, the phones that have that app running on it will be kind of the backbone for the terrestrial network. And this is, Life 360 bought Tile, right, a few years ago, and who just were the trailblazer in this space. So that's a really formidable combination. So is that the case, or am I on the wrong track?
Yes, very big, mostly yes. Relationship, we have a very strong relationship with Life 360 Tile teams. Alex, our CEO, was CTO of Life 360, and he took it public. He's our leader. Our vision. He's great. He sets the vision, brings great people. I don't know about me, but other ones.
I think he brings great people. We can just say that.
he brought Ben, and Ben brought. So I don't know. It's like skip one step here, but yeah, we have a really strong relationship. So that's sort of like the history why that particular network is a very dense network. It's the network that wants to solve this very similar problems. So we have a lot of synergy just working together. Obviously, as you said, buying Tile at some point in the past, but it's not only network. So when I say 90 million, it's a big part. I'm not gonna share specific numbers, but it's a big part, but it's not everything. So a lot of the customers we onboard want to be part of that network. It simplifies their life, so they bring their gateways into the picture. So we grow with our customers, and there are other partnerships that we're developing. You mentioned the gateway providers. So gateways is sort of becoming a kind of a third funnel. We're right now counting as part of the 90 million, but in my mind, it's a little different, because in industrial applications, where there's really high density of devices and where the Life 360 doesn't really cut it, we expand with the gateway installations. Let's say it's a warehouse, it's a Walmart. Sorry, I don't want to say we can. I don't know if you want to without working Walmart. I don't know if there's discussions, but I'm just giving an example.
Large big retailers,
dense, large retail company. So gateways is becoming a big part of our terrestrial solution as well. So it's all right now funneling into this big number, 90 million, and you can go to network.hubble.com and you can sort of actually explore our terrestrial coverage. And it's not just US, it's global. Yeah, hopefully that answers your question. Interesting.
It does. And I think that's a beautiful strategy. Networks are really the key. I mean, IoT is this slog. And I think the thing that the heart of ambient IoT is using the spirit of it is using the infrastructure that surrounds us and for communications, in some cases for energy. And so I think what you're doing, these may not be devices that cost 5 or 10 cents, but a huge cost and a huge inhibitor for IoT has been infrastructure deployment, and you are basically solving that. And to the extent that you can build networks of networks and increase the coverage so that people just don't need to think, and the answer is yes more often in terms of that coverage question. That's a great service to the whole industry, and I think all boats rise. This isn't a very techie question, but let's say I'm I don't know, some logistics company that's got tens of thousands of handsets. I want to use your network. I'm willing to open mine up. Can I actually make money out of, are there like roaming fees between the networks? Or is that?
It's a great question, and I don't know if I have the answer. This definitely comes up, but I am not in a position to say where the sales and marketing team is going, and I think it
Okay,
depends
that's fine.
from scenario to scenario. But it is definitely, if you are one of those people, talk to us. I think
Yeah.
there's opportunities. I just not the best person to talk about those.
Yeah.
Here.
So, and I'm gonna sort of half technical, half business. What can I use the terrestrial network for? My understanding is the network, part of the network is Tile and Life 360. Let's say, do I have to use? What's the nature of the tags that I have to use for it to work on those networks? I'm assuming I can't just put an iBeacon on there and have it work.
Yes, you can. It's just pretty much any device off the shelf, Bluetooth. You put in our stack. We have our, we handle the encryption, the key rotation, and everything. But it's effectively it. Like any device will work. We target industrial use cases, so we don't go after consumers. Consumers have this more or less solved. I mean, I don't want to talk against Hubble, but there is Find My. We effectively Find My, but for the industry, not for the consumers, necessarily.
I got to disagree with you there. I think that Find My is amazing, and hats off to Apple for what they did, and they've done a beautiful job in many respects. But tying it to, I've got a whole bunch of them. I can't find any now, but I want to bring all sorts of different form factors onto a network, and most importantly, I want to use AI apps and develop my own software that can be used, that can open up amazing use cases for consumers. And so really my question is, as someone that's developing Ambient Chat, an AI app that, where you can talk and use natural language to understand, who did I loan my hedge clipper to? But so that's a consumer use case. Could I use your terrestrial network for that?
Of course. I think that's the distinction is that you're completely right, and it's a great use case, and that's not excluded. It's more of who we're targeting to. We're targeting those inventors, tinkerers, entrepreneurs who want to build something for a consumer, right? We're not going directly to, you go to Costco and buy it off the shelf and configure.
Fair enough.
We're not targeting directly the consumers, but if there's usually some kind of a maker in between who has an idea and it goes to the consumer, that's completely within our realm. We do talk, there's medical devices companies that we talk to where this makes a lot of sense. So at the end, yes, it is a consumer that's benefiting from this network, but we didn't sell them directly. We sold it to someone who built this medical device.
Oh, that's great.
So I hope you see the distinction.
I do. Oh, no, that's great to hear, because I personally believe the kind of the Find My ecosystem market segment is tiny compared to what it should be. and there's a huge, lack of education and imagination because people, and what we need to do, and I feel like this personally for my company, is show people stuff working in their home so that, when the EVP of logistics says, "Hey, I can do this at home. I'm able to get this real-time visibility of basically everything I care about in my home. Why can't I do that for all of our fixed assets and inventory in this factory?" And so I think we have to show. I believe that there is a crossover between the consumer use cases, although
Of course, of
that
course.
that probably doesn't make me a good entrepreneur because the best ones are like laser focused and they're like, yeah, okay, but I'm not going to die on that hill. I'm going to just focus on tracking lemons in the third party arbitrage market in Eastern Canada. Very super focused thing. But I just never was that disciplined. I was never that
Yeah,
disciplined.
our developer first, like you're the person with customer, like it's exactly the vision we see, like, right? That's how Stripe started. Like you make it really, oh, sorry, the second one was Twilio. That's what I was thinking.
Yeah.
Right, make it really easy for people with ideas to try, and things will happen. Right, and it'll just grow. And that's what we're trying to do, right? If you have an idea, try it. Take advantage. Give a shot for our network. And yeah, that's what we love. I love it. This is my thing. Like, I'm trying to partially with my body block the mess behind me. I have boards all around me. I don't just do what I do at Hubble. I come back home and I use Hubble to build my ideas. It's a little bit of a
Nice.
special access I get, but I get the perk. But I do tinker. I'm a user of our, like, I dog food our own solutions, and I love it because, like, I have a million ideas. I want to try it. I'm gonna just put this together and put it in this environment, and yeah, let's see. Maybe it becomes a product one day. For now, I'm just learning, and it's fun.
Yeah,
So, I
I'm with
love
you.
your use case. It's exactly kind of people we want to engage.
Wonderful. Okay, so is there anything we need to else that we haven't covered that you'd like to cover on the terrestrial side? Because I don't want to. I mean, it's pretty amazing. I think it's like, obviously the satellites are. This is like Star Wars and beacons in
Mhm.
space and amazing. But actually, you have a network that it sounds like most devices can access, and there's
Yeah,
incredible coverage, and it's open for enterprise users and developers, and that's actually amazing. And so I think you on one hand, companies need to be focused, but you also kind of want to have a balance. And I can imagine the terrestrial thing could be fast growth, and the satellite beacons in space is probably going to take a little longer. So that's a good mixture. Anything
it's a
we
good
should have
mixture.
covered on the terrestrial side before we go back to what it took to put a receiver in orbit?
No, I think in terrestrial, I think we covered the main one. Just, yeah, the highlight. You want to try it? Try it. It's ready now. People, we have another Slack channel, just like people trying new companies and people experimenting with things, and it's growing. As you said, it could have been a company on its own, but we don't want to stop there. We don't want to just do this. We want to be really comprehensive, and we really see network of networks combining and making this really seamless experience. Like, that's how we really succeed, is when people stop worrying about connectivity, and it's not going to be one network. It's going to be this really seamless roaming between multiple options.
Yeah. And you're building a platform, which is great. I mean, there's a lot of good cases to be made to say, create a product, then we can make sure everything's complete. And very often startups fail because there isn't a complete solution. But you are doing the, excuse me, ballsy thing, which is, I'm going to make a platform, which is really hard, but it's what the industry needs. So tell us how you made a platform with satellites. Are those your satellites, or are you piggybacking on other people's satellites? Tell us about that bit.
Yeah, they are our satellites, but we work with amazing partners who do the buses. So we focus on our secret sauce, our part, just the payload. And then we work with Spire and Durasat, Muon.
Hmm.
It's all public. All the partnership. The companies that know how to build a bus, right? The standard, the command and control, the power systems, dealing with launch vehicles and everything. We worked with experts to do that part, and we just added our payload to it. But it's fully ours. We're not payload sharing, or like time sharing with other companies. We had we launched 7 satellites to date. We started with 2 experimental. We thought, well, there's a high chance it's not going to work. A lot of things can go wrong.
Yeah,
So we immediately we're going to launch one more as a backup. So we called those 3, like the first one, like really research and development units. But the first 2 worked. So the third one
that's
got a
great.
lot less love because we're like, okay, we're working with this one. So let's run, let's learn. One of them already deorbited. I don't know. I don't know if that's really public, but it's okay. It was a sad moment. We will learn a lot from the first units. It We didn't succeed perfectly with the propulsion system on the first 2 units, so they were slowly dropping in their orbit over time, and one eventually burned in the atmosphere. It was sad. We had our names engraved on the satellites. Like the
Oh
first team.
no.
The first like 10
Oh
people who
my
built it.
goodness. Yeah.
Yeah, and so we have like a patch now, like, and we have internal dashboard. We have like a patch, like in memory of. But he had a name Hubi. It's like one of those cartoon characters from a long time ago. The first 2 were named Hubi and Birdie, 2 mice from uh, cartoons, and
Uh-huh.
I picked the names because Hubi sounded like Hubble, and I'm like, oh, it sounds cool.
Yeah.
So Hubi has passed away, and it would not with us. So we have 6 in orbit. So after the first 3, so 2 left, and then we have 4 more, which are production satellites, which will be used for this GA that we're going with in a couple of weeks. And yeah, as you said, we work with partners to help us build those. It's been a lot of learning. We're not necessarily all experts in space. We became over time. So it's fascinating. It's honestly fascinating. Like there's all these small things that. So I think last year there was this really strong northern lights in Seattle, aurora, and
Uh-huh.
everyone's like taking pictures and everyone's excited about it. And we're paranoid because this is radiation. This is radiation that can burn a satellite. So we're
Yeah.
like,
Yeah.
what do we do? We don't really know. I mean, we have some people who kind of have some ideas what to do, but we kind of shut down half of them. Let's see what happens because the radiation is a big deal in space, and single bit upsets could happen. We were just like, hey, let's learn. So when people were taking pictures and having fun, we were like paranoid.
How big are these things? How big are the satellites?
So the current generations are CubeSats, the 16U, so that and then a bigger side of of CubeSats. I would say about 2 meter end to end.
Oh wow. That's big.
It's relative, so it unfolds, right? So when it
Oh,
launches,
okay.
it's like
So
a
you've
box. So
got
when
solar panels and
Yeah,
yeah.
so solar panels. So pretty much our hundreds of antennas that we use for beamforming, they're about the same size as solar panels. You actually would see if you go on a website, there will be like 2 sets of crosses. One would be the solar panels, and the other one is the set of antennas that unfold after the launch. So when it starts, it's about a box, a big, and then it opens the opens the panels.
So you guys had to design the wings of this thing, the antennas, obviously. So we haven't really got into the science behind getting radio waves up into space, but beamforming is where, you know, I mean, back in the Williot days, you always had this sort of people want range, but they also want coverage. And it's like Well, you can have one, or you can. I mean, it's kind of a trade-off between the two. And so with
That's right. Yeah.
beamforming, it's like having a laser can go really far because it's a very concentrated beam. So presumably that's how RF Genius is part of the reason you were able to get these beacons to talk
Yep.
to a satellite.
Yeah. And then so each beam, so we have many beams. So like we have very powerful FPGA processing a lot of signal parallel.
And what's a FPGA for?
Oh, FPGA, field programmable gate array. It's a super process. It's how not super. It's a processor where we can program dynamically as we need to, and does all the digital signal processing. So all the heavy lifting of creating all those virtual beams from the antennas that all, as satellite fly, they all point kind of a narrow beam in one location, but we have many of them, and so we process them at the same time. So this way we have the coverage, right? A single beam gives you narrow visibility, but gain, you get all the gain from it. But we create many virtual beams at the same time, and so we process all of them simultaneously. So that gives us pretty much very wide coverage between all the beams, and each beam has all this extra gain to close the link margin that we need to talk to end devices. Yeah, so that wasn't developed in-house. We have good RF engineers, really phenomenal. A relatively small team, but we do a lot, and people are great.
Well, that's the key. If you're going to do something
the key.
amazing like this, you got to have a small, great team.
That's exactly right. We have, talk about AI. Like with heavy AI users, we managed to do a lot of second-degree work with AI, but we have experts. We have relatively small team, and we can just do a lot with what we have. Yeah, team is the most important part.
Oh, I have an AI question I have to ask you. We'll go back. We haven't finished with what these satellites look like and what it took to get in the air. But to what degree are you using AI personally to write the code that you write?
I think it's across the industry, right? December, somewhere middle of December, things flipped, and it went from like, oh, it's cute, it helps, it makes some mistakes, like Copilot used to be, and to mid-December to now, Anthropic and Claude and Almost 4.6, 4.7, like, it codes. So a lot of things where, otherwise we'll have to hire a person, and just something not necessarily core to what we do, but we need to do. Maybe it's a website, maybe it's some kind of analytics. There's a lot of things that we have to do, but not necessarily our strength.
Okay.
AI comes in and does it, right? And we will double check, and it gets done. And we can still focus on things that are really unique to us, where, we use our years of experience. So we're trying to combine, and it's been very productive. It's a weird time. It's hard to predict how it's going to go, what's like next day, next month for us. But we're definitely very active in utilizing the latest tools. And as engineers, we look at this and,
yeah,
weird times.
It's a little scary. You've done some great things, so it's you don't have to worry about this impacting your career. At your level, I think you're gonna be fine. So is it true? So you've got to spin up a website. Obviously, you would use the tool for that. But you're working on that stack. The FPGA needs to be reprogrammed. Can we get another 5%? Is AI got any role in that, or not?
Not yet. That is still us. The last 5%. That's the hardest percent. We're exploring the tools. We're looking at tools for more close to metal work.
Yeah.
It's hard to say, like, if we're gonna adopt one or another.
Yeah.
A lot of interesting work going on, but generally that's not where AI has been most impactful yet.
It would be interesting to let AI roam around like the really deep stuff that you've done, and look for that AlphaGo move. Demis, the guy who's just awesome at Google, who's driving all of their AI, and they they developed this algorithm that beat Go and came up with a new move. I'm just wondering whether you could point AI at your software and says, "Hey, actually, there's another 30% here," and you're like, "What?"
I think it will happen. I think we are not far from it to use optimization, but it has to be. Well, I don't want to say, I don't want to give us so much credit. It's like, oh, we cannot do it what we do. Seeing now what it can do, I know that it's just a couple of steps away. But when it comes to like physics, or actually HDL, like, so when you program FPGA, use HDL or Verilog, it has not been great. Like, for example, AI tools have not been great with those tools. It just doesn't have enough information to be trained. Again, if someone listens, there are companies trying to make this better. I know of number they're reaching out to us, but it just hasn't been like obvious. Where like, oh yeah, it's so great in hardware description language, or very low level embedded and register work. It's good in reading documentation. That is amazing. Like, I can give a documentation on a chip, and it will give me a great summary that otherwise would take me maybe half a day to find. Yes, amazing. But actually going and writing the code, hit or miss. But again, I'm sure it's not far where it's, as you said, just let it go. So as I said, we're all sitting here, it's like, fun
So
times.
last AI question, then we'll get back to space because I want to ask about the propulsion systems. But so what are the tools that you're using to code with the AI tools? What have you tried? What do you like?
As a company, we use Anthropic. That is our number one. We use both Cursor as a development. We have this not directive, encouragement that explore, learn, teach other people, because I think that's the case right now. Just so much going on. Personally, I can speak for myself, but that's not going to be universal across the team. I use Cursor a lot, and I use Anthropic a lot, Opus 4.7. Like, that's like exclusive main tools that I use, and with all the plugins, and it's connected to a lot of the like our data warehouses. For example, I don't have to write SQL query. It's so much better than I have ever been in writing SQL query. So, yeah.
Okay. Well, I've got something I want to bounce off you once we've stopped recording, but it's basically about how you can integrate Claude Code with 5.5, GPT 5.5 and other stuff, which is something that I'm working on.
Gosh.
But let's get back to you. That's much more interesting. And so these propulsion systems, do you literally have like someone with a, I can't believe that you have someone with like a joystick that is, you're laying in course adjustments yourselves, or are you working with partners on the propulsion systems?
Yeah, so as I said, we're working with our partners. They're responsible for day-to-day management of the satellites. So keeping them, moving any orbital maneuvers, they're responsible. We ask what we specify what we need. They have the experts to get us there. We manage the tasking windows. So what we are responsible is that commands that go through the bus, right, from the ground station networks to the bus, to our payload.
And what is the bus? I've kind of nodded sagely, like I understand what that means, but what does it mean?
It's the term that describes sort of the main part of the satellite. So that's like the standard part of the satellite. That's the propulsion, that's the command and control units, that's the communication links with the ground station networks. If you imagine those big antennas, that's so when satellites fly by, the link is established for command and control. Maybe you want to do an update, or you want to download the data from the satellite. So the bus represents that standard part of the satellite.
Yeah.
And then the payload is what we build. So our partners responsible for the bus and all the operation that it does, like turning us at the right time, managing the batteries, orienting the satellite in the right direction. They do this. We thank God don't have to do this. We already have a lot to do.
Yeah.
And we are responsible, and then we just manage the payload, the commands that go to the payload, and all the function that executes, all this signal processing that it needs to do to process all this really low signal.
Okay, let's talk about use cases and applications. There's other stuff I want to ask about, which is like what happened when you first figured out the communication was working, because that seems like that would be awesome. But
Yeah, of course.
let's get into what are the use cases that you see as being the sweet spot for the satellite network.
Of course, we yet to see all the options. The same thing with the terrestrial. We had ideas, we open up the gates, and then we see people come up with ideas, and
Yes.
that's amazing to see. And I think the same thing will happen with the satellite, where we have ideas, but there's way more to be done. I can list the obvious things, right? A container, as I said, container moving through ocean. I, as a big retail company based in Seattle, want to know where my containers are because it's important for my supply chain.
How do I know where it is? Let's go. We're going to get back into the weeds of the technology. Couldn't help it. We're back. So, typically the closer you get, the easier it is to do kind of location. The further you get, the harder it is. So how do you do you're up in space, how the heck do you locate where that container is?
Multiple options, depends on how complicated your end device is. You could have GPS chip. You can have a GPS chip, it can have the location, and you can add that into the payload
Oh, okay.
going to the
Yeah.
satellite. So that's the most stable. That's one option. Then you can utilize the payload. That's something that MiFi network doesn't give you, is we give you the payload space. But flip side of having a lot of antennas on the satellite and beamforming, the flip side, the additional benefit is you can do angle of arrival computation. So each antenna, so we know where the signal is coming from by looking
Yes.
how the phase of the signal changes from each antenna. So
Yeah.
we can actually locate the device to some precision. With a CubeSat, it's less. It's not as precise. We are targeting like kilometer to kilometer precision with a CubeSat. Long term, we want to be meters with the future generations of the satellite. So that's another detail, is that we're actively working on a different, much bigger satellite, 10 times bigger, a lot more antennas. We will be able to actually support the 4 dBm, pretty much Bluetooth chips without any amplifications. So that is planned for next year. And with that, we plan to be able to locate things to meters instead of kilometers. But yeah, using the antennas gives it many antennas gives it that information to locate devices.
Yeah.
Just from the signal alone, you don't have to even tell us where you are. We will know where you are.
And so that means basically you can reduce the bill of materials on the tag, and so it becomes cheaper. And
Exactly. Yeah.
yeah. So okay, so container tracking, that seems like a good one. And yeah,
There's static use cases. So, for example, oil and gas, knowing how much you have in a container, right? You have assets. It could be water as well. So there are a lot of use cases where you have remote assets with something they're measuring, some amount of liquid or gas in a container, right, in its system, and you want to know each day how much is there right now.
Yeah.
So there's many use cases. Critical infrastructure monitoring, so the cracks, vibration, etc. In this country, infrastructure is could benefit from some visibility and from some investment into it. Sorry, I don't want to. There's a lot of opportunities. Critical infrastructure tracking, forest fire detection. Not yet. Some things that require really immediate feedback. Right now, our revisit time is 12 hours.
Okay.
So we're not necessarily tracking your dog yet because a little too long.
Right.
But the goal, like I'm really like one of the startups. I live in California. I wanted to do something about the fires. Fire prevention was like, okay, what do I do? So it's like something close to heart is fire detection. fire
Yeah.
in critical infrastructure monitoring related to fires in forests, so wires dropping, etc. So that's another set of tools and expensive assets in remote
Yeah.
sites
Yeah.
is a big opportunity because things getting lost. I mean, it's amazing if you start. It depends on the industry, but knowing where your things are, how much are they being used, are they being stolen, huge use case, and rarely connectivity is easy to
Right.
get.
So what,
Livestock.
one
Mm.
detailed question. Okay, let's use livestock as an example. How directional is the tag? Obviously, you've got incredibly directional technology up in space, but I've got a tag on the ear of this cow. It's presumably flopping around all over the place. Is that a problem?
A ref is hard. A ref is, yeah, yeah. I don't want to say that it's no problem,
Yeah.
but it's a solvable problem with good engineering,
Okay.
right? And antennas, not all antennas are the same directionality. In this case, actually, is against you. You want something more isotropic.
Yes.
We have the link margin to deal with imperfection, right? As you get closer
Oh,
to the body, impedance mismatch changes the antenna, efficiency on antenna drops. So there are tricks. Blindly, this will be hard, but it
yeah,
is a
yeah.
solvable problem if
Got
you
it.
know
But
the details.
but on a container or a tractor or that sort of stuff, then you're in pretty good shape. You've got a good line of sight, and you can figure out which way is up unless someone's
Yeah. And then just to add to it, because this regular BLE, right? Just, you can do other things that people have been doing for a while, like mesh network. So you actually can have ways to have terrestrial communication help the satellites. So you can actually do some kind of redundancy. So if you have a herd, you can combine the data and actually devices coordinate where you can drop your probability of something not being detectable by one, but maybe someone else reported on your behalf as well. So there are tricks to make system more robust by virtue of using existing options, terrestrial
Mm,
options.
very good. Well, I feel like I could talk to you all day, but you've got satellites to launch and a lot to do. So I'm going to respect your time. But if we've got time, can you just describe to me what it was like when you got the first ping from the first satellite up there? That must have been amazing.
Yeah, I think that it wasn't steps. It was definitely steps. So we first transmitted more power, and we didn't have packet. It was just like a sine wave. Okay, sine
Yeah,
wave. Got it. And Ben, we mentioned him earlier. He's our science. He's a
yes,
brains of the shop. I mean, we have many brains, but he's one of the main
yeah,
ones. He's like MATLAB something. Is like we see it. Good. All right. So then we start. Okay, go from tones to packets, but it's still one antenna. And then I'll have to do beamforming, and beamforming requires calibration on antenna. And the calibration is function of temperature and a lot of effects on in the system. So that took some time. But actually, when we started getting the first beam, we're like, that was a big step. Like sine wave, we know the system is working. We know
mm, mm.
that's less. It was exciting, but then the step function from that to packets and beams, when we got that working, we're like, okay, it works. Okay, we know how to do this. Yeah, and then we moved really fast. Within the first 3 months, we knew this was going to work, at least on the on the signal processing side. But then 2 years go from I get to play to other get to play and give them SLAs. That has been the journey now for the last 2 years, just making it robust, FCC compliant, working with all the chip vendors like that. That has been the hard part of the last couple of years. So I'm very much excited. We are weeks away to maybe start charging someone for this, and not just me playing with this on daily basis. So there's a lot of build up. I'm like, I'm so close.
Oh yes. Amazing. Well, congratulations, Art, and congratulations to everyone at Hubble, and thanks to Alex who put me in touch with you. I met him when he was at Amazon.
Yeah.
I really believe that you guys are making IoT history. So thanks for making a super interesting chapter in that
Of
IoT history
course.
book.
And I just want to just close it. I said, it's important to me, but it's important to us. Like it's team.
Oh,
I'm just a loud one in the team. I just get to do the podcast and just people around me. But the team, and I think everyone, it's a lot of hard work, fun work, and I think we as a team really have done amazing thing, and we just look forward collectively to this GA release coming up.
yeah. Well, yeah, it's a thing of beauty when you have really, really smart people who figure out how to work together and do something really big and difficult, and that's what you've done. So, Art, you have quite a storied career. You've had senior positions. You've founded your own company. How do you describe to people how you got to where you are today? Because I see, I'm seeing RFID as like one of the things is a lot of wireless, interesting wireless. There's Lockheed Martin. So Hubble is such a fascinating company. There's lots of different ingredients, but it seems like you had practice at almost all of them before you got there. How would you describe your story?
Oh, there's a lot to it's a long story, and I think I find it exciting. I think I have been lucky. I always do things that I like, and I do things that are a lot of fun, even if they are very hard sometimes
Yeah,
and very stressful. That seems like to be very correlated things. Very stressful and a lot of fun, kind of go
yeah.
together. And I think Hubble right now, actually, what I do at Hubble is like culmination of many of the experiences coming together from before. It's just funny how the life works. Right, I started in Lockheed working on interplanetary communication systems. So it was very researchy but fun project, hacking TCP/IP to deal with the Kepler equations, whatever. So
Hmm.
then I kind of moved away from space. And IoT has been a big part. Robotics IoT has been a big part of my career, and learning a lot and knowing where the pains are. Being an entrepreneur, knowing what's really where you're really spending a lot of hard time. Connectivity being a huge part of it. Like, pretty much every single startup I did, either being part of a startup or starting, connectivity always was something I had to deal with, and then
Hmm.
sometimes it was less complicated, but often it was very complicated. And yeah, and Hubble now kind of brings it all together, right? It's a space industry with IoT part, solving the pains like I really much understand.
Hmm.
So I'm solving for myself couple years back, or many for many versions of me in the past. I'm solving those problems right now myself. So it's easy to do when you know exactly the pain point you're addressing.
How did your path cross with Alex and Ben, the founders?
Yeah. So one of the first experiences, if you look at the past, after grad school, me and Ben studied together at Berkeley. We were in the same
Oh,
lab,
oh,
and
really?
Vairama. So why Ben started Vairama, I was me and Rob Barton were the first. Well, it was a team of three. Really, we started a company called Vairama. It was an RFID space, item level tagging. Our RFID was really hot at that point. It's kind of a renaissance right now, but more with Bluetooth than RFID. It's interesting right now what's going on in that item level traceability space. So anyway, me and Ben go way back, and then I was working at Zipline when Ben had this crazy idea. He's like, "Hey, I'm doing this thing." Everyone, like this doesn't make sense. Like, including me. Like, and nowadays, when I tell people what we do, they're like, "Yeah, that feels very out there." And Ben is one of those people. He's like the most genius person who has like really crazy ideas, and sometimes they're real and they work, and it's his super strength. Anyway, we talked a couple times, and I'm like, okay, I get it. I know why you're doing it. I don't know if we will be able to pull it off, but again, sounds fun. I like fun stuff. Sounds hard. I like hard stuff. Let's do it. So I joined pretty early on, before we had any satellites. And yeah, the first year was just building the first bird that we would launch and then learn from it. But that's the story of how I knew Hubble. I'm an insider.
Yeah,
I am an insider. Yeah, I knew someone who started the company.
very much so. And was at what point did you figure, oh, this is one of the crazy ideas that could actually work?
Not that the first call with Ben, no. But Ben proves his points with math, and math. You know, it's not hand waving. It's not like, yeah, I understand the story. So as I said, this was obvious what we're trying to solve. From it goes back to Vairama and Pentry. So again, connectivity,
Mhm.
item level, visibility, IoT. I get the value proposition. I understand what it means to bring a new chip into design, how hard it is, and how amazing when you don't have to do it. I mean, if it's already a part that you are very comfortable with and you can do more with this, great. And Bluetooth, nothing is more prevalent as Bluetooth chip. In terms of closing the link margin from ground to space with 100 milliwatts, yeah, couple meetings with Ben, understanding the physics, the math, and then I kind of jumped on board. And then at that point, it was kind of on me. I mean, being part of the team to actually make it real, right? We know the math is there, but we have to do a lot of things right, like a lot of things, from basic physics to satellite design. So a lot of new things. Do we know it's going to work or work that well even with the first satellite? No. I think we still sometimes don't believe ourselves and have to
Mhm.
sometimes step back and look at the results. Like, hey, I just transmitted from this little board, this little Seeds IO MG24 board that's 100 milliwatts, and it's from Seattle HQ, and I'm seeing it past California, like just pretty far. And we have to step back, like this is really cool, but sometimes still hard to believe ourselves.
Amazing, amazing. And just obviously, I take it that you grew up in Ukraine or Russia.
Correct. Yeah. Yeah.
Yeah. And when did you come over? Because according to LinkedIn, you did all your degrees,
Yeah.
multiple degrees at Berkeley.
Yeah, I came in '97, so it's been a while. The accent is
Yeah.
staying; it's here forever. I'm fine. But yeah, I have been here for a long time. Have been in Bay Area most of my life now. Sorry, I was in Bay Area, and I'm in Seattle now, loving it.
Yeah.
And people who hate Seattle weather, they don't know. It's when it's good, it's really good.
Oh, it's amazing. The summers are just awesome.
It's amazing right now. I'll have back and forth with my VP of engineering. He's like, "Oh, California is great." I'm like, I've been to California. I know it's okay, but Seattle, it's just it's special. I'm kind of settling here now. But yeah, most of the life was in the area. Berkeley was a big part of it. Yeah, loved my alma mater.
Very good.
Still, every time I'm in the area, I usually go there just to walk around, pretend I'm a student, which is not.
Yeah.
Yeah, it's been a minute now.
We're at this incubator, Ambient Chats at this incubator. So I get to cycle through the UCSD campus
Mm,
a couple of times a week, and I just love that. And
yeah.
I could be the grandfather of most of the people that are there. But anyway, it's time for
You never know.
music.
People never know, right? You're just a professor. So,
Yeah, I like to think that I look like a professor. Okay, so 3 songs. I'm really looking forward to hearing which ones that you chose, songs that have
oh
meaning for
God.
you, and why they have meaning. That's actually the most interesting thing, to be honest. It's the why,
Yeah.
not the what.
I won't say I'm not like a super into music. It's a thing that I enjoy,
Yeah, yeah.
it was actually not easy. It's like, what do you like? So, cut three songs. First, something so I would say even probably boring in many ways. I didn't know about Queen for a big part of my life.
Hmm.
I actually kind of embarrassed. I learned of Queen very kind of late into being an adult, and then I heard the "Can't Stop Me Now," and I'm like, it's so cool. I mean, I listened to the whole, like I started like really catching up. So I'm embarrassed to say, but I fell in love with the band, and it became song for a lot of things when I'm on a long bicycle ride or high. Just like it's a
Yes.
great motivational song.
Yes. I love that one too. Yeah. Off of
Yeah, so "Can't
Jazz.
Stop Me
Yeah.
Now" from Queen is
Yeah.
one. There's this I don't know if you ever heard of this artist Mark Farina. He is the DJ from kind of Chicago, San Francisco area. He has this line of albums called Mushroom Jazz.
Hmm.
It's like acid jazz. It's kind of down tempo and this Kali spaces. It's nothing super special. I think to me it's important because I lived in San Francisco, so early 2000, and I kind of missed their early 90s house scene in San Francisco, but it was still rolling through in early 2000s, still quiet, still going strong. And I think that's when I first kind of left the house, left the university, and I have some money. I live
Mm.
in San Francisco, and that song of that artist was kind of representation of that early part of my life, right? My 20s, and stuck with me as just anthem of yeah, just everything in front of you, ahead of you, and opportunities in San Francisco in early 2000. Just recovering from .coms, a lot of the entrepreneurship
Yes.
happening. So
Yeah.
that's kind of that's the second song. The third song you definitely haven't heard because it's in Russian.
Okay.
It's this artist that I would never really listen to. Super pop stuff. His name is VAVAN. Doesn't matter. But there's a song about bicycling. It's called Bicycle, but in Russian, velosiped. And it's just fun. I have this hobby every year. I try to do a very long bike ride, like 1,000 kilometer kind of a bike ride through a new country,
Oh my God.
with my best childhood friend.
Yeah.
And that
That's
song is
great.
our and that song is our theme song. So we just kind of we start with ride, we start that song, and like, okay, let's do this, 2 weeks of off-grid cycling. So the three
Uh,
songs.
and what are some of the countries that you've cycled through with this friend?
So we used to do more backpacking. Now we do cycling.
Okay.
We did like off the grid Canada. So we did Denmark. We're going to do Croatia this year, so really looking forward. I missed last year because I had a newborn, and I just couldn't get away. I just
No.
couldn't get away. I have three
Yeah.
dogs, a newborn, and no support network in Seattle. And my wife was like trying to be accommodating, but I could see that would be hard on her.
Yeah.
So I is like, yeah, I'm not gonna do this year. I will skip.
But that's a great tradition. I really love that thought. That's great. Well, Art, thank you so much for sharing a little bit about you and wrapping up our interview together. Thanks for coming on the show.
Thank you, Steve.
So that was Art, and a lot of fun talking to him. I really enjoyed it. I hope you did too. As is traditional, let me share with you what I have been listening to this week, and it's Joe Jackson's latest album called Hope and Fury, and it's amazing. This is a guy who became popular in the 80s. I remember seeing him when I was a student at Wembley Arena doing the big world tour. And he's one of the British artists that crossed over and made it big with his music in the States. You may remember Look Sharp, Is She Really Going Out with him, and Night and Day. So he's actually just brought out this album, and it's Music from the perspective of someone who's in the later years of their life. So this is not sappy love songs or being jilted. Is she really going out with him? This is reflections on society and what it's like to grow old and having your voice heard. But it's also got an amazing beat. It's kind of an incredible mixture of Latin, jazz, funk, and rock. I highly recommend it. And I get to see him live in LA later this month. So I'm super excited because he's great live as well. So Joe Jackson, check him out. Thank you very much for listening. Thank you very much to our sponsors, Bleakon and Identiv. It's come to the time of year which I least look forward to in doing this podcast, which is going out and asking our sponsors to sign up for another season. And they all did it very graciously. So thank you very much, because without them, we couldn't do it. Without Aaron Hammock, we couldn't do this either. And of course, without you, this would be completely impossible. So I appreciate it. If you have been, thanks for listening. Thanks for watching this episode of the Mr. Beacon Ambient IoT podcast. You can also listen on Apple Podcasts, Spotify, or wherever you get your podcasts. Please like and share this video and be sure to subscribe so you don't miss further episodes. For more information about our sponsors, head over to blecon.net, identiv.com, and ambientChat.ai.